Jai Hind students. This is the 5 lecture series of the subject Telemetry Principle, which is the core subject of department elective subject of instrumentation, electronic instrumentation engineering. In the first unit, that is basically about the telemetry systems and its classification. So, I want to start with the what is telemetry. Actually, when we are talking about the telemetry, basically telemetry comes from the combination of two Greek words that is related to remote and meter with reference to the measuring. So, combinedly it is known as when you are making any measurement at a distance or a remote location. So, the point comes here that when we are talking about telemetry, actually our measurement is at a distant location or it is inaccessible. So, let us understand this thing with an example, such as you are working on a glacier. You all know that in today's scenario, when global warming is a very prime issue in the current scenario, then you have to monitor all the health of the various geographical locations, including glaciers, oceans and various points. So, when we are talking about the glacier, then if you know about the Wadia Institute of Geological Sciences in Dehradun, that is basically collecting the data from the glaciers, and that data is about the temperature changes, about the wind speeds and the other geographical conditions which is going to measure from the glacier end. So, when you are talking about this point, you can understand that glacier is located at the very high altitude, and there is not possibility of person that they permanently lived there and taking the data and sending to the main control processing unit or the control station. So, in the previous years, how they are collecting the data? In the summers, a group of 3 or 4 scientists with the trackers, they are going to the required place or at the glacier, then they are placing the sensors there and they came back to the ground station. Then after some time of the winters, they go back again that same location and collect the data from the instrument. But during this period of 3 to 4 months, there is a possibility of storms or geographical adverse geographical condition that sensors may be totally completely you can see that destroyed due to the atmospheric condition. So, the next technology which came into the mind, that is about the how we can access that data in real time from that location throughout the year. So, for that this telemetry concept is used there. In that you are placing a transmitter section at the glacier with some sensors, then that sensors collecting the data, they are combining that data into a single signal, and through the transmitter they are sending that data to the ground station, and at the ground station there is a receiver which is receiving the data. It means you can see that you have a complete you can say that you have a complete block or you have a complete system. That system is known as telemetry system, and that telemetry system work on the telemetry principles. So, in the our main aim is we have to take the data from the remote location so that we can access that data in the real time at a distant location. So, when we are talking about this, this is the basic step involved in the telemetry. You can see here the first step is conversion. In conversion step, what you are doing? Actually, in telemetry, you are using the sensors, and that sensors are actually taking the physical quantity and sensing that physical quantity and converting it into the electrical signal. So that same process is going to be done by transducer or sensors, and here you have to understand that all transducers are sensors, but not all sensors are transducer always. That point is basically related to the your instrumentation part, in which you can see that when we are talking about the transducer definition, basically transducer is when one quantity, physical quantity, is converting into the another quantity, that is transducer. But when we are talking about sensor, that sensor is the instrument or equipment that is basically converting the physical quantity into the electrical signal. So the first step involved in this telemetry is conversion. In conversion, you are actually converting that measurement quantity into the electrical signal. Then the transmission. In transmission part, we are sending the data, that converted data, to the remote location, from the remote location to the ground station through the wire or wireless medium. It means in transmission we have a channel, and that channel is actually combined with a transmitter, means you are collecting the data, converting the data, then that converted data is applied to a transmitter, in which you are performing the modulation, amplification and other processes, and after that you are transmitting that data through the wire or wireless channel to the ground station or to the central processing unit. So then after receiving that data, you have another place at the receiver side, means that is conversion. At reconversion, this is the receiver part, means that is the ground station. Here what we are doing, actually at this receiving part, what is going to happen, you are getting a electrical signal or modulated electrical signal. So first of all you are going to demodulate the signal, and after demodulation of the signal, you are going to convert that signal into the again into the physical quantity through the another systems, that is such as for audio signal it is a speaker. So this is all about the basic step involved in the telemetry. Now this is the basic block diagram of telemetry system. In university examination, this is a major question which is going to be asked, and if you understand this, you can see here, this is the sending end, means this is the transmitter. Here this is channel and this is receiver. So here you can see that you are getting the physical quantity or physical variable at the measure end, means at the remote location. Then that data is converted into the electrical signal by using transducer or sensor. Then you are performing the signal conditioning. Actually, why we are using this signal conditioning? When transducer or sensor converting the data from physical to electrical signal, due to the transducer and sensors limitation, that signal is quite weak, and that signal is not able to be processed by this transmitter. So first of all, you are applying a signal conditioner. Signal conditioner is basically making the signal compatible to the transmitter. That's why we are using this signal conditioner. Then that compatible signal is applied to the transmitter, where modulation and multiplexing is going to be done. Why we are using this modulation? Because by the modulation we are actually converting the low frequency signal into the high frequency signal, so that the signal can travel to the long distance. And for the multiplexing, as you know that at the transmitter part there are a number of sensors, and that sensors are creating the data by sensor 1, sensor 2, sensor 3, sensor 4. It means we have n number of inputs, and we have to send that n inputs through a single channel. That's why we require multiplexing. So it means there are three basic processes. First one is conversion, second is conditioning, and third one is modulation as well as multiplexing. So this is the main thing. So then we are sending that multiplexing plus modulated data to the channel. Now this channel, basically this channel may be a wired channel or they may be a wireless channel. When our distance is more than 50 or 100 meters, we are using the wireless channel. For the less than that, we are using a wired channel. So that wired or wireless channel is as per the requirement or as per the specification of the system. So at the receiver end, what we are getting? We are getting a modulated multiplex signal. So in the receiver part, we are using the reverse of this, means we are performing demodulation and demultiplexing. We are performing these both steps at the receiver side. Now we are getting that data. Now that data is going to apply to the end device, and end device may be a recording device, may be a analytical device, may be a storage device, or may be a display device. So as per the device, we have to condition the received signal so that that can be applied to the end device and the necessary action can be performed. So this is the basic block diagram of telemetry system, and this complete block diagram is going to be asked in the university examination as per the previous year question paper. So now, when we are designing any telemetry system, there are some factors which we always have to take into consideration before designing the telemetry system, and that basic criteria are: first one is primary criteria, that is choice and design is accuracy. Means whenever you are designing a telemetry system, your first choice of design is accuracy, because if you are getting the data from a distant location and you are not getting it accurate, it means that it is just a wastage of resources. Then the transmitted data is in analog or digital domain, means you have to identify the signal which is you going to transfer, that is in a analog domain or in the digital domain, because as per the analog or digital domain, you have to design the complete system by using the analog signal processing or digital signal processing. Similarly, when we are talking about the digital data, in digital data, we have to identify the error correction, error detection and recognition capabilities of that particular system to make it accurate. So in the digital part, you have to identify and taking consideration of error detection and correction capability of the system. Similarly, bandwidth is also a very crucial issue. So that's why for a individual telemetry system, it is required to select a appropriate bandwidth and link to avoid the interference. Also, the power level must be low to reduce the noise, whether the signal to noise ratio of the system must be high, so that the noise associated with the signal can be reduced. So these are the main factors. Sometimes this question is also asked in the university examination. Now, classification. So when we are talking about the classification of the telemetry system, there are various bases. In the first one, that basis is transmission channel, means which kind of transmission channel you are going to use, if that is a wired channel or if that is a wireless channel. If we are talking about a wired channel, I told you earlier that range is 50 meter to 1 kilometer, means you can use the wired or landline telemetry system for a 1 kilometer range, but nowadays this is limited to 100 meters only due to some other consideration, because landline telemetry system is basically related to landline telephony, which is not quite popular in these days. That's why, and this wired telephony is used for power lines, electrical wires and telephone lines. So the second part is wireless or RF system, the RF telemetry system. The range of this wireless system, telemetry system, is around 1 kilometer to 50 kilometers, and it work into the frequency range of 20 kilohertz to 300 gigahertz, and they are actually using a 4 megahertz carrier for that signal, and also for greater than 50 kilometer they are using the microwave link, which range is 890 megahertz to 30 gigahertz. And in this complete wireless system, as you are going to cover the complete earth, you can cover the complete earth. So if your distance between the ground station and the sensor part or the transmitter part is increasing, then after a selective range, you are going to place the repeaters at every 30 to 60 kilometer in case of long distance transmission. So basically what is that repeater? Repeater is basically a device which is actually getting the signal, and that noise associated with the signal is going to be removed, then signal will be amplified and again sending to the next location. Means this is your location 1, this is your location 2. When the distance between this is greater than 50, means 150 kilometer, then what you are going to do, after every 50 kilometers you are going to place a repeater circuit. And what is going to be here, that signal is coming here at this point, because as soon as signal leaves the transmitter, noise will be introduced in the signal, and as soon as the distance will be increased, that noise will also increase. So after a fixed distance of 50 kilometer, that signal is collected by the repeater. Repeater first receive the signal, then amplify or filter, noise filter the signal, and then again transmitted to the next place. So this is the use of repeater. Similarly, in this wireless we have not any physical link, and this is for example, this is in a spacecraft, rockets, missiles, all that using the RF telemetry system. So next classification is on the basis of available signal, that I already told you, that on the basis of available signal there are two kinds of signal. First one is electrical signal. Electrical signal, this is the one. Electrical signal means you are getting the physical data, going to convert it into the electrical signal, and that electrical signal is going to be used for the telemetry system. That's why it is known as electrical telemetry system. The most common example is voltage and current telemetry. Other than that, pulse telemetry, frequency telemetry is also there. But second type of available signal is non-electrical telemetry system. In non-electrical telemetry system, actually you are not converting the physical quantity into the electrical signal. Means if you have displacement, you are directly using that displacement into the system for the transmission. Similarly, you use that hydraulic system, pneumatic system. So as per that non-electrical telemetry system, we have hydraulic, mechanical, pneumatic telemetry system. Similarly, the third one is on the basis of signal output. When we are talking about the signal output, if output signal is analog, then it is analog telemetry system, and if digital, then it is a digital telemetry system. And the various example of that system are PAM, PPM, PWM telemetry system for the analog, and for digital that is PCM telemetry system. So these are the classification. Now we are going to discuss one by one various important telemetry system which is regularly asked in the university example, and among them voltage telemetry is the first one. In voltage telemetry system, if you are taking a simple example of your electrical and electronics engineering knowledge, you always know that whenever we want to calculate the voltage across any resistor, we always connect it into the parallel. But when we are talking about the current, then it is connected into the series. Then that same concept is going to be applied in this voltage telemetry system. How? You can understand here. As I told you, in a basic telemetry system there are three parts: transmitter, channel and receiver. You can see that this is the transmitting end. Means here you are getting the physical quantity and converting that into the electrical signal. This is the receiving end, where you are getting the signal through the channel, and you are going to apply it on the instrument as per your requirement. So you can see here, this is a potentiometric arrangement. You can see this is a Burden tube. Burden tube is basically a primary transducer. As per the definition of transducer, primary transducer is that transducer which converts the physical quantity into the another intermediate physical quantity. You can see here, In burden tube, you are actually applying the pressure. When the pressure is applying on this burden tube, its dimensions will change as per the compression and expansion, and due to the compression and expansion, the slider wire connected with this burden tube will move or will create displacement. So that displacement will change this variable resistance, and due to that change in resistance, the voltage drop across this point will also change. Means that voltage change is calibrated with reference to the pressure applied to the burden tube. Now that voltage is, as I told you that voltage is basically when we are want to measure the voltage, we have to apply it into connect the instrument into the parallel. That's why you can see also here this receiving end is connected with this potentiometer in parallel combination. So this is about the voltage telemetry system. At the receiver side, there is a potential scale calibrated in kilonewton per meter square, and the data is coming here in the form of voltage, and you are taking the data in the display. Similarly, when we are talking about the current telemetry system, all arrangements are same. All arrangements are same. The only change is, as I told you, now connected into the series. So here you can see that this is the same burden tube, pressure is applied on it, it will be converted into the displacement, and that displacement change the slider position. That is going to change the overall current flowing in this circuit, and you can see here this ammeter part or the current metering part is connected with this transmitter through the wired channel in series. So this is the part related to the current telemetry system, and you can understand here very clearly that in voltage telemetry you are connected that in parallel, in current you are connected in series. Here we are using voltage parameter as the variable, and here we are using the current as the system. So working of both voltage and current telemetry system are same, but there are some just construction point of view changes in the system. Then next is merits and demerits. You can easily identify that. Effective for short distance, V and I can be easily transmitted, circuitry required are simple, wide variety of primary sensing element. Or demerits are demand high signal to noise ratio, need to be protected from EMI, and multiplexing is difficult, and limited frequency response. Similarly, the other point is frequency telemetry system. In frequency telemetry system, you have to identify one thing. The primary change of the input signal through the transducer is just in the form of V or I. So how we are applying this into the frequency telemetry system? We are taking the sensor input from here, transducer converting it into voltage or current. Then after signal circuit, we are converting that V or I signal into the frequency signal, and for that we are using voltage to frequency converter or current to frequency converter. Here you can easily understand that this is the voltage controlled oscillator. You know that voltage controlled oscillator is that oscillator which create n number of frequencies as per the applied voltage. Means the oscillation frequency is going to be controlled by applied voltage. It means if you are applying any voltage value, a corresponding oscillator frequency will be generated here. So you can see that V is going to be converted into the F. So that's why it is a frequency telemetry system. Now this signal is applied to transmitter, and in this frequency telemetry system we are actually converting the V or I into the frequency part, and that frequency signal is going to be sent to the distant place by the wireless medium, and remaining all points are the same as the previous discussion. Similarly, we have a pulse telemetry system. In pulse telemetry system, just one change, you are using the pulse analog transmission, means PAM, PWM, that is the applying. Here you can see that these are the input, means various sensors, sensor 1, sensor 2, sensor 3 and sensors. They are going to apply to the commutator to perform the TDM, time division multiplexing, because for the analog part we are using frequency division multiplexing, whether in the digital we are using the time division multiplexing. Then same transmitter, then receiver side synchronizer and output channel selector. So basically this is all about the pulse telemetry part, or you can say that this is all about the important topic of electrical telemetry system. Till now we understand the electrical telemetry system. Now we are going to concentrate on non-electrical telemetry system. The very first example of non-electrical telemetry system is mechanical telemetry. You can see here, here is a platform. That platform is connected through the levers arrangement to this scale. You can see here, the load is going to be applied on this platform. As soon as you apply that load on this plane, the levers connected with this platform is going to change its position, and due to this change in position, the connected meter scale is going to be change its position, and you are getting the related reading of that applied load. So that is all about the basic you can see that here calibration between the levers and the scale. And another part CP is basically related to the counterpart. That counterpart is actually applied to balance out this load with this scale. So this complete system you can easily identify one point. Not any type of electrical signal is used in this system to get the output. So you can here see that you are directly applying the load, means force, that is going to convert into the displacement. That displacement is going to be applied to this lever, and that displacement is directly showing on the calibrated scale. So this is mechanical telemetry, means non-electrical telemetry. Similarly, second one is pneumatic telemetry. When we are talking about the pneumatic telemetry, you can see here by this example. In this example, you can see that there is a tank. In this tank, a fluid is filled, and we have to identify the level of that fluid. So what we are doing, we are here apply a pneumatic lines, means pressurized air line, in which we are applying two different bellows. These are the bellows A, B, C, D. A, B, C, D, four bellows are basically made of elastic material. They are balloon type structure, and the compressed air is filled in this complete system. At A and B, we are connecting a stroke lever with this push rod and a pivot lever to this floater. And in the C and D, there is not a direct link between them, whether there is a scale, calibrated scale. So what is going to be happen? As soon as this floater changes position due to the change in the level of the fluid, you can see that the connected pivot lever will change the push rod location, and this push rod apply the stroke on the stroke lever. Due to that stroke, this bellows or interface disc is going to change its position, means they are going to change the pressure in the A and B balloons. So what is going to happen? By this stroke, whether A, B is going to expand or going to contract. So in the both cases, the pressure in this pneumatic line is going to be changed, and due to that change, the position of the C and D balloons is also will be changed. That's why the point related to the scale connected to this C and D link is showing the output at a calibrated scale. So here you can see that there is no use of electrical signal. You are just making some mechanical arrangements. The level is converted, level changing is applied through the displacement to the stroke, that their stroke is converting that pressure, and that pressure changing pressure is going to show on the pneumatic part. Here we are using the air, compressed air as a medium. Similarly, if we are using a compressed fluid, then it will become hydraulic telemetry. Remaining all arrangement are same. Here this is the actuating cylinder in which you are applying that lever. Red part is showing the pressure, whether green part is showing the return, and that pink part is showing the suction. So basically, in previous one pneumatic telemetry we are using the compressed air, here you are using the compressed fluid. So this is all about the first unit and the important topic of first unit from the telemetry system, and these are the advantage and disadvantage of non-electrical telemetry system, and that are quite self-explanatory. So in the next lecture we will discuss about the second unit. Till then, thank you.